Okay, I'm going to try to help you in case you've gotten stuck on a couple of these problems toward the end. On number 14, what I'm going to be looking at is writing an equation for this piecewise graph. So if you write an equation, the first thing you need to look at is how many different pieces to this graph there are. So there's two pieces. So I would generally start with just a f of x equals, and then I can do a big curly brace. And since there's two pieces, I'm going to know there's going to be two rules. And then I'm going to have a domain restriction with each one. For this piece on this side, I'm going to highlight it in green. The domain restriction there would be that x is less than 0. So that would be the appropriate domain restriction, that x is less than 0. And then on this one, on the other side, I'll get a different color code it, and we'll do this one blue. All of the values there are x is greater than 0. And since this is a closed circle, I'm going to need to make that a greater than equal to 0. These domain restrictions are based on your x values again, has nothing to do with the y whatsoever. So I go ahead and set up the number of rules I have, get my domain restrictions, and then I worry about what the rules are. I'm going to start with the blue graph. The blue graph is a constant graph, so I would expect it just to have a single number. And the number value all the way along the blue graph is 3. So there I have a value of 3 when x is greater than 0. That part of the function is done. Going back to the one that's green, I might have this graph here. I'm going to need to go ahead and look for some kind of linear function. Remember, a linear function is going to be mx plus b, where m is the slope and b is the y-intercept. On this one, the y-intercept is easy to see. It does touch the axis at 0. Just a note, if you end up with one like number 15 and you need a y-intercept, you can always just kind of go backwards and figure out where it would touch the y-intercept if you extended that straight line, and that's helpful on a problem like that. On the other one, I need to find my slope. The slope, remember, is how slanted the line is. So in this case, I'm going to have to find exact points. 0, 0 is clearly an exact point. This one and this one are close, but they don't quite hit exactly. The next exact point's way over there. So what I end up doing is going down all this way and over all this way. So this particular graph has a slope of -7 since it went down, and 5 since it went over 5. So the slope is always rise over run. So the slope in this one is -7 over 5. Switching back to my green to write it in here to color code, I have a -7/5 x. And I could put the plus 0, but that's totally optional. So that's the rule for when I have x is less than 0, and then 3 for when it's greater than 0. You do not have to color code, but I've had several students in the past say that it is helpful when they color code their piecewise functions so they can see which part of the graph goes with which part of the function. It just helps with their understanding. We'll look at 16 very quickly. 16 is a problem involving the post office. Let's see. So I'm going to go ahead and mark my axis. In this case, if you take some time to read the problem, there is no value that can be negative. There's no way they're going to, and I'm going to put the weights, the independent variable there, and then I'll put the weight in pounds, and then I'll put the cost to mail it there. And it says initially they're going to charge a cost of $4 to mail it. So I'm going to start there at $4 with a closed circle. And then I'm going to have an open circle right there at 1. So that's just going to be a little step of a graph, not very big at all. Then what happens is after it weighs 1 pound, they add $1 to the price. So at 1 pound, they add it, and it costs $5. And then I'm going to have to go over and make that an open circle there. And then after 2 pounds, they add another $1. You're just going to keep going along like this. And then at 3 pounds, they add another $1. How long do I have to do this? Well, the problem says until it's 5 pounds. So at 4 pounds, they add another $1. And then it says packages over 5 pounds have different weights that we don't have to worry about in this problem. So this is the piecewise function. It's actually a step function. You can see how it looks like little stair steps. And this is commonly used for shipping, some kind of rate plans like phones. They'll step up your charge by a big amount if you go over a certain number of minutes. So very commonly used in the real world.